You ever just look at a Formula One car and wonder how on earth it goes from a sketch on a computer to this 200-mile-per-hour marvel on the track? Well, that's exactly what we're going to do. We're going to pull back the curtain on the whole incredible journey, from a digital ghost to a full-on carbon fiber beast.
I mean, this quote just says it all, doesn't it? The fastest laboratory in the world. It's perfect because F1 isn't just a race. It's really this high-speed, high-stakes experiment in physics and material science. And every single race weekend, the rules of what we thought was possible, they just get completely rewritten.
And you know, the cars themselves have gone through this insane transformation. If you go back to the 50s, they were basically just souped-up road cars. Kind of scary, right? But then, 1994 happened. The tragic death of Ayrton Senna became this pivotal moment that forced a complete top-to-bottom revolution in safety. And that revolution is what led directly to the ultra-strong, ultra-light carbon fiber rockets we see on the grid today.
All right, so here's a quick roadmap for our journey today. We're going to start with that fastest laboratory concept, then jump into how these cars are designed in what's essentially digital wind. From there, we'll see how they forge a carbon fiber beast, put it through a trial by fire and data, talk about the rulebook that governs everything, and finally, take a peek at the never-ending evolution of F1. Sound good? Let's get into it.
Okay, so let's dive into this first section, because at the very heart of every single F1 car, there's this fundamental conflict. It's this constant battle between the relentless push for more speed, more performance, and the absolutely non-negotiable demand for driver safety. And a perfect example of this is what's called the survival cell. This is the carbon fiber monocoque, the tub, basically, that surrounds the driver. In a crash, it has one job, and one job only: stay completely intact, no matter what. It has to protect the driver from these just unimaginable forces. I mean, it's so strong, it's designed to withstand the equivalent of a double-decker bus being dropped right on it. And yeah, this is a direct legacy of that safety revolution that happened after 1994.
So how does a physical marvel like that even begin? Well, it all starts in the digital world. Long before a single piece of carbon fiber is ever laid, an F1 car exists only as pure data, sculpted by the laws of physics inside these incredibly powerful computer simulations. Okay, to really get your head around the digital design part, you need to understand one crucial concept: downforce. Think of it like a giant invisible hand that's just slamming the car onto the track. The wings, the floor, the whole bodywork, it's all designed to generate this force. And that downforce, well, that's the secret sauce. That's what lets these cars take corners at speeds that would literally send your family car flying into a wall. But, and this is the big but, here's the constant battle that engineers are always fighting. They want to maximize that downforce for insane grip in the corners, right? But the more downforce you create, the more drag you also create. And drag is like having an invisible parachute trying to slow the car down on the straights. So the entire game is finding that perfect razor's edge balance between those two opposing forces. Nail that, and you unlock a blistering lap time. So how do they find that balance? Well, they use some pretty incredible tools. One of the most critical is something called computational fluid dynamics, or CFD. The easiest way to think about it is like a virtual wind tunnel that lives inside a supercomputer. It allows engineers to simulate exactly how air will flow over literally thousands of different designs, without ever having to build a single crazy expensive physical part. It's a total game changer. All right, so once that digital blueprint is as close to perfect as it can get, it's finally time to bring it into the real world. This is the moment the car goes from being just data and pixels to a physical carbon fiber beast that's ready to hit the track. And that construction process is this super methodical three-phase journey. It all starts with those detailed 3D designs we talked about. Then hundreds of specialists get to work manufacturing every single individual part, and they often test them right to their breaking point, just to be sure. And then finally, over a period of several weeks, all of those thousands of tested components are meticulously assembled into the final car. Now, the real secret to all of this, it's the material. The car is built almost entirely from carbon fiber composites. And why is that? It's because this stuff is basically a miracle material. It's actually stronger than steel, but it weighs just a fraction of it. I mean, think about that. It is the absolute perfect ingredient for a machine that has to be both blindingly fast and incredibly safe. Okay, but just because the car is built, that doesn't mean it's ready to go. Not even close. Now it has to survive this absolutely brutal gauntlet of tests. They're designed to prove it can handle the extreme forces of a race weekend and, maybe most importantly, a severe crash. And just to give you an idea of the kinds of forces we're talking about, check this out. For the 2026 season, the roll hoop, that's the structure right above the driver's head, it has to be able to withstand 167 kilonewtons of force. So what does that even mean? Well, that's the same as the weight of about 17 tons. Or if you want a better visual, imagine nearly 3 adult elephants pushing down on it. All of that incredible strength is there for one reason, to protect the driver if the car flips over. So you see these insane numbers, right? But it begs the question, how do the teams and the governing body, the FAA, actually prove that the car is safe enough to race? Well, the answer is a whole series of mandatory crash tests. And yeah, it's as brutal as it sounds. Before any car is allowed on the grid, its chassis is literally physically smashed from the front, the sides, and the rear. The safety structures are crushed under immense loads, and panels are tested to make absolutely sure nothing can intrude into that survival cell. It's a really violent process, but it is absolutely vital. Now, it's super important to remember that all of this amazing innovation doesn't just happen in a vacuum. Oh no. Every single design choice, every tiny winglet, is shaped, guided, and sometimes, constrained by a massive document, the FIA's technical regulations. It's the rule book that governs all. And speaking of regulations, if we look ahead to the massive rule change coming in 2026, the goals are really clear. There's this huge push for sustainability with brand new fuels. Safety measures, believe it or not, are getting even stricter. And the aerodynamics are being completely rethought, all in the name of creating closer, more exciting wheel-to-wheel racing. And I think a really key takeaway here is the commitment to sustainability. The 2026 rules are mandating that all fuel has to be 100% advanced sustainable. We're talking fuel sourced from things like non-food biomass, municipal waste, like literally garbage, or other renewable sources. So once again, F1 is using its platform as the fastest laboratory to pioneer some really vital green technologies for the future. And that, naturally, brings us to our final section. In a sport that is literally defined by constant, nonstop change, what does the future of F1 car design and construction even look like? Well, it looks like the future is being shaped by two really powerful forces, AI and something called circularity. Teams are already using artificial intelligence to help them invent entirely new materials that are lighter and stronger than anything we've seen before. And at the same time, you have teams like McLaren aiming for a fully circular F1 car by 2030. That means a car built from recycled and reused components, like reclaimed carbon fiber, to slash its environmental footprint to almost nothing. Which kind of leaves us with this final big question, doesn't it? The sport has evolved in ways that are almost unimaginable over its first 70-plus years. So, with artificial intelligence designing brand new materials, cars running on fully sustainable fuels, and this idea of a completely circular car on the horizon, what kind of incredible, mind-bending advancements will the next 70 years of innovation bring to the fastest laboratory in the world?